Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So today we are starting question number 4 from Miscellaneous Exercise of Mathematical Logic. If you are new on my channel, please subscribe the channel and hit the bell icon so that you will get the notification of newly upload videos. See, in this question, one set A is given to us and element of this set are 1, 2, 3, 4, 5, 6, 7, 8, 9, and for the element of this set A, we have to determine the truth value of the following statement. Truth value means we have to check that whether the statement is true or what false. So see the first example, there exists means what? There exists at least one element in this set which satisfies the given condition. Let us check whether the at least one element of this set satisfies this condition or not. In case of there exists, if at least one element satisfies, at that time we can say that the statement is, the sentence or the statement is what? True. So there exists x belongs to A such that x plus 8 is equal to 15. So if we are taking addition of 8 with 7, at that time only the addition will be equal to what? 15. Means x should be equals to 7. Let us check whether 7 lies in this set or not. Yes, 7 is the element of this set, means there exists one element in set A which satisfies this condition. So that's why we can say that this statement is true. But it is true for which element? For x is equal to 7 belongs to set A. And as the statement is true, that's why we can say that the truth value of this statement is what? T. Now let us try to solve this example. So here we have what is the given statement for every x, means we have to check that every element satisfies given condition or not. What is the condition? X plus 5 is less than 12. X plus 5 is less than what? 12. So let us check whether the 1, yes, definitely 1 satisfies, 2 also satisfies, 3, 4, even 5 and 6. 6 also satisfies this condition because 6 plus 5 is what? 11, and 11 is less than 12. Even 6 also 6 does not satisfy, 6 also satisfies. Let us check 7. 7 plus 5 is equal to 12, but addition should be what? Less than 12, means 7, 8 and 9 does not satisfy this condition. So that's why we can say that this statement is false. This statement is false for x is equals to which element? For x is equal to 7, 8, 9 belongs to this set. For this element, this condition is not satisfying because our statement is what? For every element. But these three element does not satisfy this condition. So we can say that truth value is what? F. Truth value of the given statement is F. Observe the next statement. There exists x belongs to A such that x plus 7 is greater than or equals to 11. There exists means there exists at least one element which satisfies this condition or not. So that addition should be greater than or equal to 11. So when this addition will be equal to 11, if x is equal to 4, means for 4, 5, 6, 7, 8, 9, this addition is either equal to 11 or greater than 11. Means we can say that this statement is true because there exists means what? There exists at least one element, but there are many elements which satisfy this condition. And which are these elements? This element is true for x is equal to, just now we have seen that if I am replacing x by 4, so we are getting 4 plus 7 is equal to 11, and if we are taking value greater than 4, at that time also this condition is satisfying, means the number is greater than what? 11, means this condition is satisfying for 4, 5, 6, 7, 8, 9 belongs to which set? A. And that's why we can say that truth value of this statement is T. Now here observe the example number 4. For every x belongs to A, 3x is less than or equals to 12. Means we have to check that this condition is satisfying for every element. Means if at least one element does not satisfy, we can say that it is false. So here if I am taking x is equal to 8, 8 3s are 24, means 24 satisfies this condition. Means if I am taking x is equals to 8, 8 3s are 24, means if 8 satisfies, means remaining all these elements satisfy. Let us check whether 9 satisfies this condition or not. If I am taking x is equal to 9, 9 into 3 is what? 27, and 27 is what? Greater than 25, means this condition is not satisfying for x is equals to 9, and here for every is there, every means if every element satisfies this condition, at that time we can say that it is true, but one element does not satisfy, that's why we can say that it is false, and false for x is equals to 9 belongings to set A, and hence we can say that truth value is f. In this way we have completed question number 4. Now we are starting question number 5. In question number 5 we have to write down the negation of the following given statement. So let us try to find out negation of the first statement. Already we have seen that if every appears, means for every appears, at that time while writing negation we are replacing it by what? There exists. So there exists n belongs to n such that since we are finding negation, so we can say that n plus 7 is not greater than what? 6. Not greater than 6. This will be the negation of the given statement. Observe the next statement. There exists. Now there exists will get replaced by what? For every x belongs to A. Here what is the condition? X plus 9 is less than or equals to 15, means its negation will become x plus 9 is not less than or equals to 15. Not less than or equals to 15 can also be replaced by greater than 15. That is our choice. Either write down less than or equals to 15, and not less than or equals to 15 means what? Greater than. Means you are able to use greater than also instead of not less than. Now sum will get replaced by what? For every or for all, or simply every. Some triangles are not equilateral triangles, so we can say that every triangles are equilateral triangle. So in this way we have got the negation of the given statements. Now let us try to solve the example from question number 6, in which some logical statement patterns are given to us and we have to construct the truth table of this statement pattern. So see, the first statement is P implies in bracket Q implies P. So if you will observe the given statement, two letters are there. Two letters are there means we have to construct the truth table for 4 possibilities. So here first we are finding value of Q implies P. In case of implication, what we have seen, if first statement is true and second statement is false, at that time only implication is false. So here this is first statement, this is second statement. So TF does not appear, so here we will get true. Here if first statement is false, then implication is always true. TF is there because Q is first statement. TF appears, so implication is false. FF appears, so implication is what? True. Now we have to find out implication of P and Q implies P, means we have to find out implication of these two statements. Again we have to use the same condition that implication is false if first statement is true and second statement is false. So here TF does not appear, so true. TF does not appear, so true. And if first statement is false, then implication is always true, whatever may be the truth value of second statement. In this way we have got the truth value of this statement pattern. Now see the second example. In this case also, if you will observe the given statement, two letters are there, so we have to construct the truth table for these 4 different possibilities. So if you will observe the statement, here we will require the truth value of negation P also and negation Q also. So first we are finding negation of P from the truth value of P. So negation of true is false, again negation of true is false, and negation of false will be what? True. Now let us try to find out negation of Q from the truth value of Q. Again use the same method. Negation of true is false, negation of false is true, negation of true is false, and negation of false is what? True. Now we are connecting these two statements, means negation P and negation Q by which logical connective? OR. And in case of OR, what we have seen, if at least one statement is true, OR will be true. So here both are false, so result will be what? False. So one statement is true, here true, true, true appears, and we know that OR will be true if at least one statement is true. Now find out first P and Q and later on its negation. So first we are finding P and Q. So these are the truth value of P and Q, and we know that AND will be false if at least one of the two statement is false. Here both are true, so result is true. Here false, 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 means if at least one statement is false, truth value of AND will be false. Now we are finding negation of this P and Q, negation of P and Q. So observe the truth value of P and Q, we are finding its negation, means negation of true is false, negation of false is true, again negation of false is true, negation of false is true. Lastly, we have to connect this statement whose truth value appears in column number 5 and this statement whose truth value appears in column number 7 by which logical connective? Double implication, means 5 double implication 7, isn't it? So let us try to find out truth value of 5 double implication 7. In case of double implication, what we have seen, if truth values are identical, double implication will be true, otherwise it is false. So observe the column number 5 and column number 7. So here truth values are identical, so true, truth values are identical, so true, here also truth values are identical, so true, and here also truth value is identical, then true. Means double implication is true if truth values are identical, otherwise it is false. Now see the example number 3. Here also if you observe the statement pattern, 2 letters, means 2 statements are under consideration. So again we are getting 4 different possibilities of truth value. If you'll observe the given statement, here we will require the truth value of negation P and negation Q. So negation of true will be what? False, and negation of false will be what? True. Now find out negation of Q from the truth value of Q. Negation of true is false, negation of false is true, negation of true is false, and negation of false will be true. Now we are connecting these two statements by which logical connective? AND, means negation P and negation Q. And in case of AND, simply we have to remember that if at least one statement is false, result will be false. So false, 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 means here we will get false, 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 and lastly what? True. Now we are finding negation of this whole statement, means negation of negation P and negation Q. So already truth value of negation P and negation Q is known to us. Now we are finding its negation. So negation of false will be true. So here we will get true, 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 and lastly negation of true is what? False. Now we are connecting this whole statement with Q by what? OR. So write down this whole statement, means negation of negation P and negation Q, and we are finding its OR with Q, means this column and this column we are connecting by which logical connective? OR. And in case of OR, simply we have to remember that if at least one statement is true, OR will be true. So here true appears, here also true, true, and lastly in the last case false. So true, 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 false, because OR will be true if at least one of them is true. So here true, true, true is there. So here we are getting true, and in the last case both the statements are false. That's why OR will be false. In this way we have constructed the truth table of this statement. Now see the example number 4. If you observe the statement P, Q, R, means 3 statements are under consideration, and if 3 statements are under consideration, we have to construct the truth table for these 8 different possibilities. So observe the given statement. To find out truth value of this first part, first we will require the truth value of P and Q. In case of AND, we know that if at least one statement is false, AND will be false. So here true, true, here false, 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 means in first 2 cases we are getting true because both the statement are true, and we know that AND will be false if at least one statement is what? False. So that's why in remaining cases we are getting false. Now we are connecting this P and Q with which statement? R, by which logical connective? OR, means these 2 statements we have to connect by OR, and in case of OR, if at least one statement is true, OR will be true. Here in first 2 cases true, third case is also true. True, 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 then false, true, false, true, again false, true, false, false, true, false, because if at least one statement is true, OR will be true. In this way we have got the truth value of this statement which lies in column number 5. Now to find out truth value of this second statement, first we will require the value of negation of R. Observe the truth value of R, we are finding its negation. So negation of true is false, then negation of false is true, negation of true is false, negation of false is true, then false, true, false, true. In this way we have got negation of from the truth value of R. Now we are finding value of P and Q. Sorry, here value of P and Q is already known to us. Only we are connecting these 2 statements by OR, means negation R or P and Q. And we know that these two statements, if we are connecting by OR, then at least one statement is true, result will be true, and the truth value of this statement lies in which column? 7. Well, now connect these two statements by OR. So true, true, false. True, true, false. Later on, true, false, true, false, true. True, false, true, false, true, because OR will be true if at least one of the two statement is true. Lastly, we are connecting this statement 5 and this statement 7 by which logical connective? AND. In case of AND, simply remember that if at least one statement is false, truth value of AND will be false. So observe here, true, true. Again, one statement is false. So here we will get true, true, false. False, 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 means at least one statement is false and will be what? False. So in this way we have got the truth value of this statement. So TT, then F are the truth value of this statement. Now observe the last example from this question. So in this case also PQR means three statements are under consideration. So here also we have to construct the truth table for these 8 different possibilities. So let us try to find out truth value of this first part. For that purpose we will require negation of P. So observe, these are the truth values of P. From that we are finding its negation. So negation of this true will be false. So false, 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 false. The negation of false will be true. True, 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 true. Now we are connecting negation P with Q by which logical connective? Or negation P or Q. So means these two statements we are connecting by OR, and in case of OR, if at least one statement is true and OR will be true. So here true, true, then false, false, and then true, 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 true means true, true, false, false, and later on at least one statement is true either, that's why OR will be true. In this way we have got the truth value of this first part. Now we are finding a truth value of Q implies R. In case of implication, if TF appears, at that time only implication is false, otherwise true. So here TT is there means true, TF appears means false, TF does not appear, TF does not appear, TF does not appear. So true, true, true. Here TF appears, so false, and here TF does not appear, so true, true. Implication is false, only first statement is true and second statement is false. Later on we are connecting these two statements. Truth value of this statement lies in column number 5 and truth value of this statement lies in column number 6, and these two columns we have to connect by which logical connective? And truth value of this whole statement lies in now which column? 7. Okay, well, now connect these two statements, means column number 5 and column number 6 by AND. In case of AND, if at least one statement is false, AND will be false. So here true, because false does not appear, so false, 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 then both are true, so result will be true. Here at least one statement is false, so result is false. Both are true, both are true, so in this case we are getting true. In this way we have got the truth value of first part. Now find out implication of P and R. So observe the truth value of P and R, and in case of implication, if TF appears, at that time only implication is what? False. So here TF does not appear, so true. Here TF appears, so false. Here TF does not appear, so true. Here TF appears, so false. And in remaining cases, if you observe the first statement is false, and if first statement is false, then whatever may be the truth value of second statement, implication is always what? True. Now truth value of this statement means P implies R lies in which column? 8. Lastly we have to find out what? 7 implies 8. Means 7 implies 8 means the truth value of this whole statement, because truth value of first part appears in column number 7 and this part appears in column number 8, and these two parts we have to connect by what? Implication. Again, in case of implication, simply remember the same thing, that if TF appears, at that time only implication is false. So here TF does not appear, so true, true, first statement is false, then implication is always true, whatever may be the truth value of second part. So here TT is there, so true. Here also T up does not appear, so true. Here also T up does not appear, so true. Here also T up does not appear, so true. In this way we have constructed the truth table of this statement pattern, and if you observe the truth values here, so all in every possibility, in every case we are getting true, means we can say that this statement pattern is tautology. But in this question only the question is to construct the truth table, not question is not to check whether it is tautology, contradiction or contingency. So not necessary to write that it is tautology or contradiction or contingency, isn't it? Only our aim is to construct the truth table. So in this way we have completed this question number 6. Now see the question number 7. In question number 7, some statements are given to us and we have to check whether the given statement pattern are tautology, contradiction or contingency. So using truth table, let us check whether the given statement pattern are tautology, contradiction or contingency. Already we have seen the definition of tautology, means the statement which is always true is called as tautology. The statement which is always false is called as contradiction, and the statement pattern which is neither tautology nor contradiction is called as what? Contingency. So let us solve the first example. Here if you observe the given statement, two letter means two statements are under consideration. So we are getting these four possibilities of truth value. If you observe the given statement, here we will require truth value of negation P also and negation Q also. So we are finding truth value of negation P and truth value of negation Q. So obtain the truth value of negation P from the truth value of P. Negation of true is false, negation of true is false, and negation of false will be true. Using same method we are finding negation of Q. So negation of true is false, negation of false is true, negation of true is false, and negation of false is what? True. Then here we are finding implication of P and Q. We know that implication is false only if first statement is true and second is false. Means if TF appears, at that time implication is false. So here both are true, so result is true. TF appears, so implication is false. If first statement is false, implication is always what? True. Now we are finding and means conjunction of what? P implies Q. P implies Q means its truth value appears in column number 5, and negation Q appears in column number 4. Means in short we are connecting these 4 and 5 by which logical connective? And in case of and, if at least one statement is false, and will be false. So here false, false, false. So false, false, false. Here false does not appear, so we can say that and will be true. In this way we have got the truth value of this whole part, and its truth value lies in column number what? 6. So 6 implies negation P. So observe, these are the truth value of negation P, and these are the truth values of this whole statement which appears in column number 6. This is first statement, this is second statement, and we know that implication is false if TF appears, means first statement is true and second is false. So here F is there in the first statement because this is first part, and we know that implication is always true if first statement is what? False. Not necessary to check what is the truth value of second part. Now here first statement is true, check that second statement is also true, means T up does not appear, so here we are getting true, and that's why we can say that this statement pattern is tautology. Now observe the second example. In the second example also two letters appears in this whole statement, means two statements are under consideration. So we have to construct the truth table for these four possibilities. If you will observe the given statement, we will require the truth value of negation P also and negation Q also. So first find out negation P and negation Q. Negation P, from the truth value of P we will get its negation: false, false, true, true. Now find out negation of Q. So here we will get false, true, false, true. Now find out OR of P and Q. So in case of OR, if at least one statement is true, OR will be true. So true, 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 and here we will get false. True, 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 false. Now we are connecting P or Q, means column number 5, with negation Q by AND. Negation Q means what? 3. Means observe these two columns we are connecting by AND. In case of AND, if at least one statement is false, AND will be false. So false, false, both are true means true, and here also one statement is false means false, false, true, false. In this way we have got the truth value of this first part, which lies in column number what? 6. Now 6 and this negation Q means 4. We are connecting by AND. So let us try to find out AND of 6 and 4. And in case of AND, if at least one statement is false, AND will be false. So false, 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 false. Means if at least one statement is false, AND will be false. And since this statement is always false, we can say that it is what? Contradiction. So this statement pattern is contradiction. So in this way we have solved the second example also. Now let us try to solve the third example. In the third example also, if you will observe the whole statement, only 2 letters appears, means we have to construct the truth table for 4 possibilities. So here we will require the truth value of first P implies Q, find out implication of P and Q. So in case of implication, T of appears, at that time only implication is false, otherwise implication is true, and T of appears only in this second case. At that time implication is what? False. Now to find out truth value of second part, we will require negation of Q. So find out negation of this Q. What result we will get? False, true, false, true. Now we are connecting this statement and this statement by which logical connective? AND. And in case of AND, if at least one statement is false, AND will be false. So here one statement is false, so result is false. Here both are true, so result is true. Here at least one statement is false, AND will be what? False. Lastly, this statement P implies Q, whose truth value appears in column number 3, and this statement whose truth value appears in column number 5, we are connecting by AND. Means column number 3 and column number 5 we are connecting by which logical connective? AND. Again remember, in case of AND, if at least one statement is false, result is false. So here one is false, here false, false, false. So means this statement is always false, and such statement is called as what? Contradiction. Now observe the example number 4. In this example, how many letters are there? P, Q, R, means 3 statements are under consideration. So in such cases we have to construct the truth table for all 8 possibilities. So let us try to construct the truth table. So here to find out truth value of first part, we will require truth value of what? Q implies R. So Q implies R. We know that implication is false if T of appears. Here T of is not there, so true. Here T of appears, so false. If first statement is false, implication is true. Here both are true, so result is true. Here T of appears, so false. Again T of does not appear, so in remaining 2 cases we are getting what? True. Now we are finding P implies Q implies R. Q implies R lies in which column? 4. Means P implies 4. Again implication is there, so T of appears, implication is false. So T of does not appear, so true. T of appears, so false. T of does not appears, T of does not appears. So here we will get true, and if first statement is false, we know that implication is always true. If first statement is false, not necessary to check what is the truth value of second part. Now to find out truth value of this second part, we will require the truth value of what? P and Q. So let us try to find out AND of these 2 statements, and in case of AND, one statement is false, AND will be false. So true, true, false, 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 false. Means what result we are getting? True, true, then false, 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 isn't it? Now this P implies Q. P and Q. P and Q means what? 6. 6 implies to R. R lies in third column, so 6 implies to R. And in case of implication, just now we have seen that if first statement is true and second is false, implication is false. So T of does not appears, so it is true. Again TF appears, so it is false. And here we can observe that if first statement is false, then whatever may be the second part, implication is always true. So means here we are getting true, 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 true. Lastly, now we have got the truth value of this statement also, which lies in column number 7, and truth value of this statement lies in column number 5. So 5 and 7 we are connecting by double implication. 5 double implication 7, and in case of double implication, if truth values are identical, at that time double implication is what? True. So observe the column number 5 and 7. So here TT, FF, TT means truth values are identical. So in every case, what result we are getting? True. We know that double implication is true if truth values are identical, and here in every case truth values are identical. That's why we can say that double implication is what? True. And since this statement is always true, we can say that it is what? Tautology. Now observe the next example, example number 5th. In this example number 5th also, two statements are under consideration, means 4 possibilities of truth values are there. So to find out truth value of this statement, first we will require P implies Q. So find out implication of this P and Q. Here TF appears, that's why implication is false, otherwise implication is true. Now we are connecting this P implies Q and P by which logical connective? AND. In case of AND, if at least one statement is false, AND will be false. So here F. In the first case, F does not appear, so in first case we can say that this statement is true, otherwise it is false. Lastly, this statement means which statement? P and P implies Q implies to what? Q. Means this is first statement, this is second statement, and these two statement we have to connect by what? Implication. Implication means what? First is true, second is false, implication is false. So here TF does not appear, so it is true. Here also, if first statement is false, not necessary to check what is the truth value of second part, because we know that implication is true if first statement is false, if first statement is true and second statement is false. But if first statement is false, then implication is always what? True. In this way, we have got the truth value of this statement, and if you observe the truth value, it is always true. That's why we can say that this statement is tautology. Now observe the next example. If you observe the next example, example number 6, here two statements are under consideration. So that's why here 4 possibilities of truth values are there. And if you observe the statement PQ, two letters are there, means 4 possibilities are there. So we have to find out negation P also and negation Q also. So first find out negation P and negation Q. So observe, these are the truth value of P from which we will get its negation. False, false, true, true. Now observing the truth value of Q, find out its negation. So here we will get false, true, false, true. Now P and Q. So we are connecting these two statements by AND, and in case of AND, if at least one statement is false, AND will be false. So here true, false, false, false. So true, false, false, false. Later on, find out truth value of negation P and Q. So means we are connecting negation P and this Q by which logical connective? AND. In case of AND, if at least one statement is false, AND will be false. Observe here negation P and this Q. False, false, true, false. False, false, true, false. अगर एक भी F आता है तो AND क्या हो जाता है? False. Later on, P or negation Q. Observe, these are truth value of P and these are truth value of negation Q. And here we are connecting these truth value by which logical connective? OR. And in case of OR, we know that at least one statement is true, result will be true. So here true, true. Again here both are false and here true. Means at least one statement is true, result will be true. So true, true, false, true. Once the truth value of third part is known to us, lastly find out a truth value of negation P and negation Q. Means these two statements we are connecting by what? AND. And in case of AND, if at least one statement is false, result is false. So false, 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 true. So here we will get false, 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 and lastly what? True. Now if you observe, this first part, second part, third part and fourth part are connected by which logical connective? OR. Means this statement appears in which column? 5. This statement appears in 6 and they are connected by OR. Means 5 or 6. Again OR 7 and lastly or this statement appears in column number 8. Means these 4 statements we have to connect by or, and in case of or, if at least one statement is true, or will be true. So observe the truth here, at least one T appears. Yes, here T appears, so it will be true. Here also T appears, so it will be true. Here also T appears, so it will be true. Here T appears, so it will be true. If at least one of the 4 statement is true, or will be true, because we are connecting them by what? Or. And in this case we have proved that this statement is always true, and such statement is called as what? Tautology. Now observe the next example. In the 7th example, 3 statements are under consideration. That's why we have to construct the truth table for 8 different possibilities. If you'll observe the statement, we will require truth value of negation P and negation Q. So first we are finding negation of P and negation of Q. Observe, these are truth value of P, we are finding its negation. Negation of true is what? False. And negation of false will be true. So here we'll get T. Now find out negation of Q. Negation of true is what? False. Again, negation of false is what? True. Negation of true is false. And lastly, negation of this false will be equal to true. Now focus on this statement. First we have to find out P or negation Q. P or negation Q. Observe, these are the truth value of P and these are the truth value of what? Negation Q. And we are connecting these 2 statements by which logical connective? Or. So in case of or, at least one statement is true, result will be true. So true. Again here both are false. Again both are false. True. Means what result we are getting here? True, false, true. Now let us try to find out truth value of negation P and Q. Negation P and Q. So observe, these are the truth value of negation P and these are the truth value of Q. And in case of and, if at least one statement is false, and will be false. So here false, then true, false. Means false, true, false. In this way we have got the truth value of this statement. Now these 2 statements we are connecting by or. Truth value of this statement lies in column number 6, or truth value of this statement lies in column number 7. And these 2 statements we are connecting by which logical connective? Or. In case of or, at least one statement is true or will be true here. So true. So here we are getting true. Lastly, we are connecting this first part with R by what? And. This whole statement lies in which column? 8 and R. In case of and, if at least one statement is false, and will be false. So not necessary to check what is the truth value of this whole statement. It is always true. Just check the truth value of R. In case of R, here F appears, means at this 4 point statement will be what? False, because at least one F appears and will be false. Means what result we are getting? TF. And if you will observe the truth value, these are neither tautology nor contradiction. That's why we can say that the given statement is what? Contingency. In this way, we are observing that the given statement pattern are tautology, contradiction or contingency by constructing their truth table. So in this way we have completed question number 7. Only one example is remaining, and that example is very easy. That's why we left it as an practice for you. In the next video we will start question number 8.